In this video, I just want to show you how to analyze a distributed load on a beam. But I want you to remember that line drawings are not what we're doing as engineers. We're not designing lines, we're designing beams. So here's a beam, a pre-stressed concrete beam, and it's about 8 meters long, and it looks like this, right? It's got dead load, meaning it's got weight. This is how we represent it when we do our structural analysis. Now you can see there's quite a bit of difference between a line and the actual beam. Usually we put the line through the centroid, and I don't know where the centroid on this beam is. I'd have to figure it out. But the line represents the beam in our calculations. So we'll go back to that. And in this little example, I just want to show you how to analyze a distributed load. So it's distributed along the top. And we're going to say that this is the weight of the beam. It's a little much, but I wanted to put some numbers in so we can do a little math. On the one end, I'm going to assume a pin connection. On the other end, I'm going to assume a roller connection. And that's because we only have 3 equations of equilibrium, so we can only have 3 unknowns. All right, let's give it a try. In this case, I've got a distributed load of 3 kilonewtons per meter. I've got a pin at one end, A, and a roller at the other end, and the beam is 8 meters long. Always start off by drawing a free body diagram. In this case, a pin can take 2 forces, and I have AX and I have AY. And on this side, a roller can take 1 force in the vertical, so I've got BY. And usually you have a coordinate system so you can figure out what's going on. I'm going to sum the forces in the X direction first, and they set equal to 0 because nothing's moving. And I get AX equals 0. Just because AX is equal to 0 just means that there's no external force pushing on the beam. You have to have that support, or if there ever was a force, it would fall off the supports, right, without the AX locking it into place. Sum the moments around A equals 0. It's in equilibrium, if I can say the word. Let's look at the equation. Minus 3 kilonewtons per meter, that's the distributed load. It acts on the whole beam 8 meters, and the centroid of that force is 4 meters from the left support. It's right in the middle of the beam. Plus By times 8 meters, which is the distance, times the force, equals 0. By equals 12 kilonewtons, and I'm going to guess that AY equals 12 kilonewtons because this is kind of an equal load spread out between the 2 vertical components. But let's check. We're solving for AY, the only unknown left, summing the forces in the Y. AY equals 12 kilonewtons.